Welcome to another GCBASIC demonstration for the PIC18FxQ24. This one is all about using CLC, part 17. So, like and subscribe, let the video run all the way through. Don't have to listen to me, just let it run all the way through. And those metrics are so important. So why am I showing this screen? This is a description of it. Essentially, I'm saying there are configurable logic cells in this chip, and in reality, there's 8 of them. But what are configurable logic cells, or CLCs? Well, this is essentially the last technology video. I'll be covering other parts of the toolchain and assembly and stuff in the next few videos, but this is the last big one. This really shows you some great capabilities in the microcontrollers. I've assumed you've installed the GCBASIC, you've got it programming, you've got a Q24, 4 LEDs, potentiometer, and a switch and a USB TTL. We're not going to be using all of that today, because all we're going to be using today is the Q24 here. I have 4 LEDs hooked up and a switch. They're all connected to this back rail here into this Q24, programming it through a PIC18. Great. I am not using the serial today, so not really don't really have to go into the VDDIO2, but if you were using the serial, maybe you want to put it out on sorry, I'll just go back. If you're going to put it on RC6 or any of the green ones, you must apply power to, let me put the pen on. If you're going to use any of the green ones in this power domain, you must put power on VDDIO2. I've got a switch on A3 and some LEDs, which I shall show you on the next screen. I have a switch on port A3, and I have 4 LEDs on port B, 1, 2, 3, 0, 1, 2, 3. Yep, that's those 4 LEDs. And what's going to happen is when I push the switch down on A3, these 4 LEDs will come on, and there is no program logic to make that happen. It all happens within the configurable logic cell. So what it allows you to do is define custom logic functions in the hardware. There's no CPU intervention. This goes on all the time. There's no interrupts. It's just in the hardware. And you can create quite complex logic functions. You might want to use it because you can do ands, ors, you can do flip-flops, sequential logic, different inputs. I'm going to have an input as a switch, but it could be a timer, external interrupt, etc. And you can put the output can go to other parts of the microcontroller or back into another CLC. And we've got 8 CLCs on this chip, so you could have very complicated custom logic. Or you can send it as I am to an I/O pin. And you can generate applications like bespoke pulse width modulated signals. I've done that, and there's demonstrations on that, right the way through to LED controls, which actually required CLC. CLC itself is simply put, has a set of inputs, set of logic gates, some rules that you can actually then sequentially logic that all together, and then an output. Now, I've shown 4 of the signals as inputs in this top right-hand box, but let me draw a diagram. I can have an input. My input is going to be a switch on signal A. It's going to go down into an XOR gate, and that XOR gate is going to go out to an I/O pin. And it's pins, because I'm going to put the output to 4 LEDs. 1 input to 4 outputs, no code. What you could do, you could take that logic, you could say, right, I'll go through signal A, I'll do an AND, and I'll have that go back out to a peripheral, and that peripheral could be another input signal, where you could then go, right, where do I want to go? I want to go through an OR gate and do some other logic, and then I'll push it out to some I/O pins or etc. or timers or whatever. You can daisy chain these together. My diagram shows 4 A, B, C, and D, but in reality there's 8, and they're called CLC1 to CLC8. But that gets a little bit more complicated because Microchip have not used that naming convention either. They use 0 to 7. Think of it like this. Now there's 8 of these. I can only show 4 on my diagram. But what I'm going to do is I'm going to use a CLC input, and you have to tell it what that input is. And look, as complicated as this is, it says the word PPS. So it's obviously got something to do with peripheral select. And you can, in that drop-down menu, you'll find timers, etc. But if you want an input port, like an I/O, you have to do it through PPS. You have to say where it's attached to. I've attached it into this gate. Then it will come through here, and it will get inverted at the end. So the primary input signal is always going to be a CLC. For me, it's going to be a CLC. I'm going to use a XOR gate, and I'm going to actually not that gate in the final stage. I can show you that working. Might be best before we go into an example. Let me show you how it works. This is my switch I have selected, and if I push the switch, the 4 LEDs come on, and there is no code involved. So let's look at the code, and we'll look at how we go about doing that. Well, you can use MPLABX, Microchip Standalone MCC. To some extent, you can do the PPS with PPS tool, but the best thing to use would be Standalone MCC. However, for the Q24, it doesn't quite work at the moment, so I'm hoping by the time you get there, it's actually working, because I've had to handcraft this demonstration. Because using MCC, you can actually get the CLC control and the pins for the PPS from the setup files. And those files are in these types of folders. So I'll just erase my ink. They're in MC generated files, and you can actually find them in the system and CLC folders. And you can lift that program and put it inside of GCBASIC. Quite easy. Let's have a look at what I did. So in GC code, Control B, open up 290 using CLC. Control B to shut that window. Here I've got Q24 option explicit. I've got some PPS, but you can see that's handcrafted. I handcrafted that. And then there's some CLC. And all CLC is a set of registers. And that registers takes and describes your logic. The rest of this header here is the same header as before to set the hardware up, and look, no code. So if I compile that with function key F6, we're going to look at how much memory is used. Well, there's no subroutines, use 72 words, and no RAM. There is no logic to make that work. But if I program it, I'm going to program it twice. It's found it's done it. So let's look at what we can just use to demonstrate. The first part is the PPS, and the PPS says I want my CLC channel 0, which is the first one, by the way. I said it was improperly named. CLC1 has a name of 0, and I've said connect that to RA3. And where did this value come from? The data sheet. These values, I've said I want CLC1 to go to my 4 LEDs. I'll just show you what you can do. Look, if I program that, I'm going to push the button. We should only get 2 LEDs lit up because I'm changing the output of that last gate. Reset, important, because I need to reset the PPS. Push the button, 2 LEDs flash. So what's the logic making that happen? Oh, that's the CLC registers. I've got 8 CLCs I can play with. I have selected number 2. And there's a reason I've selected number 2, is because CLC number 2, not 1, not number 2, not 0 or 1, support port B. I needed something that supported port B. And you can get that from the datasheet. And I said, select CLC 2, and this is my input side, my logic on the input side. This is the output selection, which is CLC N cell 0, and it essentially says once you've done a CLC select, you're now talking to CLC 2 all the time. This sets the outputs. This sets up the logic. Now, I'm only using one of these, so if you remember, I didn't change any of the parameters, so in reality these are all exactly the same. And on my output, I've actually done an output flop. I've actually inverted the output. Now, all these registers can come from CLC tool, and when it works properly, you can actually take the program from CLC, from MCC, sorry. You can take that source file and put it directly in. And so, what that would look like if it was working is I would come into the folder called MC generated CLC source, and in here I would find my custom logic that I was going to steal if it worked. Of course it doesn't. I can sort of show you the problem. If I go into PPS tool, our tool, PPS tool, it will show you the issue. So the input I would like to use is CLC0, which is that, and I can select from here RA3, add it in. Peripheral output, CLC3, B0. Oh, it might work actually. Our tool might work. Let me see if that looks okay. Oh, that's correct. No, the CLC has been set up correctly. That's CLC0, and that's my 4 outputs. So I've selected RA3 as my CLC input, and then finally CLC3, because if I'd selected something else like CLC, let me take CLC1, look, I don't get port B in the drop-down menu. Oh, you can't see that. CLC1, I don't get port B offered. CLC2, I don't get that offered. CLC3, oh, there it is, look. So I'll add in my outputs, and my input is on RA3, and I'm going to use CLC0. Ta-da, fine, it all works. So you could cut and paste that directly into the program and it would work, but I've already done that. So essentially what I've got is a program that has got no logic, there's no interrupt, nothing. It's just what I call CLC magic. And you can create your own custom logic, which is far more complicated than I have shown you. With that, I'm going to drop out. This is the way you can download the software from MCC standalone for Windows, or you can get it from the download location. I'd go for the first one. You can find the files in your installation. You can do the same, by the way, in MPLAB when it works properly. Merge the files to do the basic hardware configuration and compile. CLC works. Custom logic. So I'm going to call that a wrap. Enjoy.